Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Okay, hello and welcome to the Automotive Diagnostic Podcast. This is going to be episode number 3, and today we're going to talk about something that I've run into several times over the last few weeks. Many times over the years, but lately I've seen quite a bit of this. This is pin fitment, and we're referring to electrical connectors on the automotive electrical systems. Most of the time this is going to involve some sort of computer controlled system. I mean, that's pretty much everything on a vehicle nowadays anyways, but the times that I see this cause some major confusion and issues is on the computer-controlled systems. And we're actually going to be sharing a case study today, one that I recently went through at a shop to repair a vehicle for a pin fitment issue, and give you some tips to identify this and just basically make you aware of pin fitment issue. And even if you were aware of it, I mean, I've been aware of it for many, many years, but it took me a while to build it into my routine. So I am checking for pin fitment on every vehicle. We're going to share some tools that you can use to check for pin fitment and just make you aware of it so that it's on the top of your mind when you're going into an electrical issue. This is a problem that I see. I get called into shops for mobile diagnostic. I go in and try to solve the problem that they're having some issues with. And a lot of unnecessary replacement of components because of pin fitment. The case study that I'm going to tell you about today is a prime example of that. It's such a simple thing. We're talking about a male and a female connector. The female connector is going to get spread out so that the male connector is not making proper contact. Now, the entire electrical connector is plugged in. It's snapped in place. If there's a lock for that connector, it's in place. If you wiggle that connector, it's not coming loose. But inside of the connector, the male and female pins aren't making proper contact. And because you can't see this, unless you had X-ray microscopic vision to see inside the connector, it's not visible. It can really confuse people, and it does. Again, I've seen this be the cause of unnecessary component replacement. A lot of times ends up being the computer module where that connector is plugged into. So let's get into the case study. I'll explain as I go some things to check for, some ways to look for pin fitment, and we'll just jump right into it. So the vehicle that I got called in for was 2011 Chevrolet Suburban. Okay, a very common vehicle. This particular application had the electronic suspension. So this is where they have air compressor on the left rear corner of the vehicle up in the wheel well, and has some solenoids, and that compressor sends air pressure to the shocks to adjust the ride height. And there's a control module in control of this compressor so that it can turn it on and off when it needs to. And there's a ride height sensor so it can determine what the actual ride height is. You put something heavy in the back of the vehicle, it's going to pump it up so the ride height goes up. You take that out of the vehicle and it's going to lower it back down. Pretty simple. These systems have been around for a long time, nothing new here. So when I get called in, this is actually kind of good for me. The components that had been replaced on this was pretty much everything in this system. They had replaced the control module, the actual control unit that controls the system. They had replaced the air compressor assembly, which includes all the solenoids, and they had overlaid a wire. Actually, I think they replaced the entire wire. They just spliced it in for the circuit that they were having a code set for. So I come into this, and that's actually kind of good for me because everything's been replaced and they used OE parts. So it kind of limits it down to what I need to look at. I'm thinking stuff like pin fitments right away. They had actually called me in because they said the computer needed to be programmed and there was some update because they reached the limit of what they were able to do. They put all the parts in it that they were aware of, including a new wire, and it still didn't fix this problem. So a lot of times that's how I end up getting my diagnostics. It's called in for a programming. Can you program this computer so this code stops setting? And that's that's not exactly how that works unless there's a specific TSB involved for that. That was not this case. And then I'll hook up to the car and say, yeah, this isn't a programming issue. Do you want me to diagnose it? And a lot of times they're kind of at their limit. They've wasted a lot of time on this already, a lot of money into parts. They just say, yeah, figure it out for me. We'll pay you whatever you need. So it's good for me in a way because all the parts have been replaced, but you always do need to consider that there's no such thing as a new part. You could have a new part that is causing this issue. We could have created a problem along the way. Maybe this isn't the same code that we started with. Now, the tech told me it was the same code the entire time. So if that's the case, I'm going to be looking at things like pin fitment first because there's not a whole lot else left unless they made improper repair somewhere along the way or they did get a failed new part. So first off, let's check the code. Let's see what we've got. It is a C0660, which is defined in the scan tool and the service information as level control exhaust valve circuit, short to ground or open. So anytime you're short to ground or open, we're thinking low voltage. We do need to understand where this control module is watching this circuit. And it's actually a really simple circuit. So this is the exhaust solenoid. So the solenoid's built into the compressor unit. And when the computer wants to lower the suspension or vent the air pressure from the shocks, it actually grounds this solenoid. It's going to cause air release from the shocks and lower the vehicle. But understanding the circuit is important. So this solenoid is fed power. It's a 2-wire solenoid. It's fed power anytime the key is on from a separate circuit that's not involved with the computer. The computer is connected to the solenoid with a white wire that when it wants to ground this solenoid, when it wants to operate this solenoid, it's going to ground it on this white wire, activates the solenoid, and watches the ride height sensor. But as with most computer-controlled circuits, it's going to monitor the circuit for integrity. Is this circuit intact? That's where these open or short to ground or high voltage codes are going to come from. So if we consider the circuit, we have power going to a solenoid, and then we have a wire coming out the other side going to the computer. If the computer is not grounding that circuit, the transistor is not operational, there's no ground going to that circuit, the voltage actually goes through the coil of wire in the solenoid and all the way to the control module on that white wire. So the computer expects if I am not grounding that solenoid and the key's on, I should see battery voltage on that white wire. That's the expectation. This code is indicating that it does not see 12 volts on that wire when it's not grounding it. And its two options are that white wire is open or it's shorted to ground. Because if it was shorted to ground, the voltage would drop across the solenoid and you'd see 0 at the computer. Or if it was open, the 12 volts would never reach the computer. So those are its two options, and that's the definition of the code. So I think the easiest thing to do for me in this case was go to the solenoid. The solenoid's and the compressor assembly a little bit more accessible than getting to the control module. The control module's up above the spare tire. Not the easiest access in the world. I access that, and I find this white wire that comes out of the solenoid. I back probe it and I have 12 volts there, system voltage, while the key's on. So I know there's power getting to the solenoid and that it's coming through the solenoid and out. So whether the solenoid works or not, I haven't figured that out yet, but I know at least it has enough continuity to put 12 volts through there. So the next thing I'm going to do is go to the control module. A little bit more work here, drop the spare down, fish out this connector, and I actually back probe this connector at the control module while it was plugged in, and I had 12 volts there. Okay, so now we're limited down on what we're going to see. And I did fail to mention, this is a hard fault. This code is setting all the time. You clear it, comes right back. And I like that. We like that as techs because that's an easy problem to solve if it's a hard fault. If it's intermittent and we've got to do certain things to recreate it, or we don't know when it's going to be recreated, that makes it much more challenging. And pin fitments can be an intermittent issue. I was lucky in this case it wasn't. It was a hard fault. So I get to that point. I'm setting the code for the open circuit that the computer's not seeing 12 volts on this white wire, but I see 12 volts back probed at this wire. Now this is limiting me down to only a couple of options. There's an issue with the control module inside where it cannot see this 12 volts, or maybe, even though I'm back probed on the back side of this pin, maybe the female pin is not touching the male pin inside the PCM connector. So I pull the connector apart and I do a pin drag test. And this is the most important test to do for pin fitment issues, is a pin drag test. And I'm going to recommend a set here if you're going to do pin drag testing. If you go to aeswave.com, they have a U-test terminal set, and I'll put a link to that in the show notes. Awesome kit. I think I paid $150 for it. I don't know if the price is exactly the same now, but even if it's not, it's totally worth it. This kit comes with a bunch of other stuff like fuse buddies and jumper wires and airbag simulators. But the best part about this is the test leads. So you're going to have just about every terminal end built into a test lead that you could ever want, and they have banana jack style connectors so you can hook them up to your scope or your meter or whatever you need to, but you can also use these to do pin drag tests. So you have the same pin that would normally go into that female connector, because you can't see inside that connector to see that it's loose. So I find the right male pin that matches up to the one inside of this control module, and I test the pin on the female side of the connector, and it's completely loose. There's no drag. And you can verify this by going a couple pins over and testing some of the other ones. You will feel it drag. You'll feel resistance once you put that test lead in there. And that was it for this one. So what I did was I took a small pick, and these pins are really small, especially on these GM connectors, and I just crimped in the pin a little bit, the female. I just tightened it up a little bit, which I don't think is a permanent fix. I told the shop in this case, you should replace this pin, you should replace the actual terminal. But I just want to see, is this going to fix the problem? Is the control module going to be able to recognize that the circuit's complete once I do this? So I tightened that up, plugged it back in, cleared the code, code's gone, we're all set, we've identified the issue. And the shop's happy to hear this. The shop manager's not so happy to hear this, because they replaced a control module which was programmed to the vehicle, which they can't return. They replaced the compressor unit, and they spent the time to overlay the wire. And I should say, when they overlaid this wire or replaced that section of wire, they did a good repair, but they only replaced the wire up until about an inch before the connector for the control module. So again, the original pin was still in place. They just replaced the wire. They were thinking, well, maybe the wire is open. They knew the circuit, they knew where the issue was, but didn't know to look for the pin fitment issue. And that's all it was. I mean, a pin, which getting these pins isn't always necessarily easy, but cost you 25 cents for a new female terminal to put it in there, or crimp it in, tighten it up somehow. That's a really simple fix instead of thousands of dollars of parts. So I want to make everybody aware of this, if you're not already, to check for pin fitment. If I'm doing circuit tests of any type, especially if it's intermittent, if I'm going to take the time to unplug a connector from something, whether it be a sensor or an output or a control module, I'm going to check for pin fitment. It really doesn't take much time at all. You can do the entire connector. Now, some connectors have a lot of pins, but at least do the circuit that you're testing and see if you have any issues there. And all the pins should feel the same. They should all have a decent amount of drag. Now, where does this come from? Why did the terminals actually spread out like this? It's tough to say. I think it has to do with how they're made, because there's certain vehicles where you never see this happen. And I've seen a lot of these GMs, especially on the control modules, have the terminals actually open up. So I believe it's heat related, expansion, contraction. I think in the last few months that I've been seeing a lot of problems, it is correlating to the drop in temperature around the area that I'm in. We're in Minnesota. It gets down below zero here, and so we can have a lot of temperature variations and cause that metal to expand, contract. You could say it's from the heat of the current going through the circuit, but a lot of these that I see, they're on inputs. This particular one was on an output for a solenoid, but I've seen them on sensor connections as well that are very, very low current. So I don't know that it's always current. I think some of it has to do with construction of the pin, some of it has to do with heat. But either way, find a way to test for pin fitment. Don't forget to check a pin fitment. I've seen control modules replaced just for one single pin on a CAN bus wire that didn't communicate, so you can't talk to the module. All you had to do was tighten up that terminal. And it gets missed a lot. Such an easy check to do. Make it part of your routine. Make it part of what you do every time you got a connector off. Check that pin fitment. And if you don't have a bunch of extra terminals laying around, check out that kit from aeswave.com. Well worth the money. Every time I pull it out when I'm at a shop, it's like, oh, wow, where'd you get that from? That's an awesome kit. And it's really good for mobile work, too, because it zips up nice. Has a good holder for all of the terminals, the test leads, so that you have them organized. Go check that out and spend the money on it. You won't regret that at all. It's one of my favorite purchases for sure. So that's about it. That's all I have today. Thank you so much for listening. I hope you enjoyed the episode today. Now let's get out there, start fixing the world one car at a time.